moving further towards the base peak, how does this base peak actually comes? So let's see that CH3, CH2, then CH2, then we have CH2 and CH3. So this is having a molecular mass of 29 and this part is having a molecular mass of 43. So what is going to happen if we are going to put the electron gun and electrons have been bombarded? So what is going to happen if electron has been released from this position? So it would become, let's see how it would become. It would become like CH3, CH2, CH2 positive. Okay, because electron has been removed from here. And the other one would become a radical because electron has been stayed there. So now what is going to happen? This one is having a molecular mass of 43, which has been represented by a base peak. First of all, why we are seeing it as a base peak? Because it is the most longest one. And we know that why it is the most longest one, because its abundance is the maximum among all of them. So we can see that this ion is the ion which has been formed in the greater quantity. Okay, in the greater quantity. So we are getting basically this ion in maximum quantity. I hope this point is clear.
Yeah.
And now let's move further and let's see what is going to happen. So we have this CH3, CH2, and CH2. Again, the bond is going to break from this position. So how does this 29 actually comes here? How does this 29 comes here? So let's see how does this 29 actually comes here. So let's see if electron is there, and if this electron has been removed, then what is going to happen? It would create C2H5 positive plus C3H7 radical. So the molecular mass of this one is basically 29. Okay, that is 29. So it is going to form something like this. Sultan, just please 1 minute.
Okay.
Okay, so let's move further. Uh, and there is an important term that I'm going to tell you, the breaking of the molecule. The breaking of the molecule is called fragmentation. Is called fragmentation. Okay, write it down. So let's move further towards pentanone. Okay, so pentanone is basically having how many isomers? There are basically two isomers that are linked with it. That is CH3 dash C double bond O dash CH2 dash CH2 and dash CH3. Then we are going to have CH3 CH2 dash C double bond O dash CH2 and dash CH3. Okay. The total molecular mass of pentanone is basically C5H10O. So its molecular mass is 86. Now, let's see about its structure. Penta Pentanol is basically having a molecular mass that we have discussed just now, and that is 86. And we have discussed this thing that at the rightmost position, we are going to have the total molecular mass of a molecule or a compound. So let's see how from where does these peaks are going to come. So first of all, its molecule formula is CH3COCH2 CH2, and that is CH3. So if we are having this electron here and this electron here, so if what is going to happen if this electron has been lost, then we are going to have this CH3CO C2 and C2H4 is positive plus CH3 radical is going to form. So molecular mass of this one is basically equal to 71 after the loss, after the after the removal of this methyl ion. So that is 71. So bete, यहाँ पे क्या होगा? So this position is basically represented by its molecular mass. Okay. So just kindly give me
Okay.
1 minute. Okay. So in this way, we are getting this peak of 71. So how does, from where we are going to have this peak of 43? So that is CH3. We know it is having this formula C double bond O. That is then CH2, CH2, and then CH3. So you can see that this one is having a molecular mass of 43. So what is going to happen then? A bond has been going to break from this position. So electron has been removed from this position, and then this would remain as a radical. So this would become CH3CO positive plus C3H7, and there is a radical that is going to form at the top. So this one is having a molecular mass of 43, which has been represented by this peak. This peak is called as a base peak. And we have also analyzed this thing that this, you can say, ion is the ion that has been in the maximum amount, that has been present in the maximum amount. Okay. So
Okay.
it is basically clear from this place. So let's move further. Okay. So after that, there is basically some questions. In some questions, you are going to see this kind of scenario that, first of all, the relative abundance is going to be plotted here. And then we are going to have, you can see m by z is plotted here. So here we are going to see a peak, and which is represented by m plus, and this is going to be represented by another peak. Just so there's a small peak here which represents m plus 2 peak. Okay. So difference of unit between these two peaks. So this is basically represented by carbon. You can see that one carbon is having a peak of 12. Carbon is having two isotopes. Okay. So this one is 12 and the other one is having C13. Remember, this one is basically present in the maximum amount, that is 99%. And this one is already is only present in 1% amount. Like for example, if you are having CH4, then you can see that 99 of them would be having 16 gram and only one is having 17 grams. Okay,
Okay.
so what is going to happen? Uh, you can see that this peak is basically in a very small quantity, So that is basically representing carbon 12 and carbon 13. This is has been represented by carbon 12 and this has been represented by carbon 13 peak. Okay, because you can see that there's only a difference of one, okay, between them. So let's move further and let's discuss. And you can see the difference in the height of these peaks. That represent that 99% is represented by this peak and only 1% has been represented by this peak. So there might be a question that would be asked in the exam as well, in which there is the formula. There's a general formula we are going to apply there. N is equal to 100 divided by 1.1 into abundance of one thing here, we will like write it as m plus 1, just m plus 1. Okay, it is plus and it is m plus 1. Okay, so the question here is that abundance of m plus 1 ion and over it there is abundance of only M positive ion. So these things, this basically represents the number of carbon atoms. So they are going to give us like at least two of the unknown things because they represents the constant. So they are going to give us only two of the unknown things and we are going to find the remaining of them. So for example, in this question, if they have given us the abundance of M plus ion, abundance of M plus ion, and that is basically equal to, you can say that is equal to 54.5, okay? And the abundance of M plus 1 ion, that is basically equal to 3.6. Is that clear? So n would
Yeah.
be equal to 100 divided by 1.1 multiplied by, this is plus 1, so it is 3.6. Over it, that is 54.5. And that would be equal to 6.0. Is that clear?
Yeah.
Okay. So let's move further and let's discuss some of the more details related to it. So now, chlorine. Let's move towards the molecules. That one is chlorine. And we know chlorine is Cl35. That is basically present in 75%. And the other is chlorine 37. And that is basically present in 25%. Remember one thing, before we have done M plus and M plus 1, for the case of carbon, because the difference in the isotopic mass of carbon is only one, is only one. One carbon is having the mass of 12 and other carbon is having the mass of, this is 12 and other carbon is having the mass of 13. And now we have another situation this is 75%. So this is basically present in 3:1 quantity. Now, we have this CH3Cl. We know this Cl is present in has a mass of 35. And over it, there is CH3Cl is having a mass of 37. So its total mass is 50. Its total mass is 52. Now, this one is having M positive, and this one would be M plus, yes, M plus 2, Sultan, M plus 2. Why? Because the difference in the molecular mass is plus
Hmm.
2. Okay.
Yeah.
So now, if we are going to see about bromine, then okay. And if we are going to, if there would be the graph, remember the graph would be having the difference of 3:1. Its peak is going to have a difference of 3:1. So let's see bromine. Bromine is an other halogens. Remember one thing, halogens are going to show you the difference of 2. Okay, difference of 2. Like you can see bromine, one isotope is having a mass of 79, other isotope is having a mass of 81. Is that clear? And both of them are
Yeah.
present in 50%, 50% like this. So they differ in molecular mass of 2 only. Okay?
Okay.
And so this is the thing that I just want to discuss for mass spectrometry.